In this video, we will show you how to automate the meshing for electromagnetic wave frequency domain problems. This feature is going to create the mesh for our entire model geometry, including any perfectly matched layers, and the mesh is scaled based on the material properties of the model, resolving the local wavelength for each material. So the entire meshing process is completely automated for us. Here we have opened the optical scattering model in COMSOL Multiphysics, and we're going to take advantage of the symmetry of this model, which is a sphere, by only modeling a quarter of it. We have the dielectric sphere, which lies within the center of the model and is surrounded by air. And we're going to solve for the scattered field surrounding the sphere. If we look at the material properties for air, we can see it has a refractive index of 1, and our dielectric material has a refractive index of 4. We've also specified the wavelength of incident light to be 400 nanometers with the parameter wavelength. Now, to automate the meshing for electromagnetic wave problems, we can go right under the electromagnetic waves frequency domain interface, and in the settings window, under the physics controlled mesh section, we can simply select enable. Now we want to specify a maximum element size, which we've done so using our wavelength parameter and dividing it by 5. For any 3D electromagnetic wave problems, you'll want to have at least 5 elements per wavelength in each material. So now, with the simple toggle of the enable checkbox, we can return to mesh 1 and click build all to generate the mesh. And there you have it, our meshing was completely automated. We can see we have a finer mesh in the dielectric region where there is a smaller local wavelength, larger elements in the surrounding air region where the wavelength would be larger, and finally outside of that, a swept mesh consisting of triangular prisms for the perfectly matched layer domains. If we change our sequence type to a user-controlled mesh, we can see under mesh 1 the meshing for all the parts of our geometry. And we can go under any of these subnodes and further refine the meshing for that part.